title of my topic is Integrating Rough, Soft and Fuzzy Sets, a diligent approach to addressing societal issues. And this is one of the main societal issues. So I would like to explain this issue through the case study or example of my today's topic. So dear all, Honorable Professor Suhas Khoth Sir, Principal, KJ College of Engineering Management and Research, Dr. Prajakta Deshmukh Ma'am, HOD Engineering Sciences and convener of 1 week this short training program on applied mathematics in science and engineering. Coordinators of this training program, Professor Sandeep Sahane and Professor Asha Jadhav, and dear participants. I think you have aware about what do you mean by rough, soft, and fuzzy set. So I would like to explain this through one case study. Before that, let me clear one thing, one beauty of mathematics. Uh, Mathematical modeling means art of expressing something, some real life situation into mathematical model. So, analogically, we can say that mathematical modeling can be expressed as a catching or holding real world problem into your hand or teeth, jumping into the mathematical ocean, adding desired flavors of the mathematical theories as well as tools, and finally coming out to the surface with the beautiful and innovative solution of the problem. I think we all know that every real world problem has a solution. But only thing is that sometimes we don't know that solution. In near future, you may find that it is a solution. The problem of this imperfect knowledge means imprecise knowledge, has been tackled for a long time by philosophers, logicians, and mathematicians. There are many theories like fuzzy set, rough set theory, theory of vague sets, then theory of interval mathematics, soft set theory. To tackle the problems involving uncertainty means imprecise data is there. And the main objective of rough set theory is to solve problems involving uncertainty and imprecision, mimicking human-like decision making. This is the main objective of rough set theory. And in this session, I would like to combine these three theories together for our one particular example. And our example is how to select a spouse or life partner. Is it feasible to you? Okay. Now here, what do we say about this picture? Participants. A boy is proposing to a girl. There may be reverse situation. And if both are agree, then they will marry and enjoy their happy family life. This would be possible only if your selection of spouse or life partner is correct. Otherwise, you may face many problems. Dear participants, if you are married, then you have an opportunity to help your younger brother, sister, yeah, your son. And if you are unmarried, then you have to listen this session very carefully. So I would like to explain this case study. So for that, as a prerequisite, I will explain some basic properties of fuzzy set, rough set, and soft set theory, and what do you mean by some mathematical modeling. So fuzzy set theory is developed by great scientist Zade in 1965. Actually, that was defined in 1939, but first paper was published in 1965. Then rub set theory is developed by computer scientists. Rub set theory is used to mimic a decision like human being. That means for imprecise data. And soft set theory was developed in 1999. So these are recent developments in set theory. Now it is mathematical modeling. That means one line, analogically, we can say that art of winning or without actually fighting. That is mathematical model. Without performing that experiment, we can mathematically what we call find out some results. I think this one is visible to you. This slide is mathematical modeling. Is it visible? Yes.
Yes, sir.
Okay. Now model. Model means general meaning of model is different. Our understanding is different. Don't correlate this with film industry. So model means that is a representation of something. Okay. So that means college principal will be representative of that whole institute, work as a model. Some scientist is a representative of one laboratory that will be work as model. So this definition suggests that modeling is an activity, combined activity. We call it as a cognitive activity in which we think about and make models to describe how devices or objects of interest behave. For example, this picture says happiness. So instead of writing happiness, you can show this picture only. This picture says about some achievements. Okay, so that means these pictures are also one type of model. Cartoons are one type of model for that particular philosophy. Then what is a mathematical model? That model is in general. Now mathematical modeling means representation in mathematical terms of behavior of real devices and objects. Now our topic is symbol of love. So instead of giving this symbol of love to someone, we can just write equation given below. That equation is x square plus 2y square plus z square minus whole cube minus z square uh, x square z cube minus 1 by 10 y square z cube is equal to 0. If you give this equation, that means for this symbol representation, mathematical representation is this. Remember one thing, mathematics is a language, very precise and concise in terms of mathematics that depends upon your expertise. That but if you study that particular concept and in that way, then you could able to find mathematical model of any situation. Then techniques of mathematical modeling. That means if we have some real world problem, and so write, note down that problem very precisely. Statement of problem, definition of problem statement is very, very important. Then try to connect that with real world existing problems. for which we have some mathematical model. If not, then we have to design your own model. But there are some parallel mathematical models. So first find out parallel mathematics, and then as per your use abstract symbols, yeah, some constant variables, then which that may be ordinary differential equation, integral calculus. That depends upon your constraint. So use that mathematics. So convert that into mathematical model. Mathematical model means equations. Then find solution. That what you know about that. There are many methods to solve what we call mathematical equations, yeah, mathematical model. And out of all that methods, we have to find out suitable one, and then find solution, and then check that solution with real world problem, interpret that solution properly. Nowadays, many researchers are working on AI, but I think AI is old. Now, recently, AI gives some result, but how to interpret that result, how to understand meaning of that result more precisely, that is very, very important. And for that, again, we required mathematics. Mathematics plays a vital role in AI and artificial intelligence. So this is about technique. That means one flow of getting mathematical model. Now, for a rough set, fuzzy set, and soft set, you must know what do you mean by set. Hmm. I came to know that this one is a heterogeneous group. That means some mathematics, physics, then computer professors are there. That's why I will just explain some basics, and then I will start, because we have to understand our actual application. So these are just prerequisites of our application. Set is a collection of well-defined objects. That means set of participants who are teaching mathematics here, who did PhD in mathematics. So this one is precise, well-defined collection. Set of all professors, set of all people in teaching community. That may be school teacher, all teaching community, like this one. So that depends. Set depends. We required some basics, union, intersection, and complement for a rough and soft set, because this plays very important role there. So union means A union B. It is a collection of elements in A as well as B. That's why these two. And intersection means we have this portion only. That means common elements. Okay. And union means all elements. Elements in A and B. Now, complement means A complement means which are not in A. So here, mathematically, we can express that X belongs to A complement if X is not a member of A. This is mathematical representation. And in general, representation is elements which are not in A. So here, A minus B. Now, if A intersection B is non-empty, then from set A, remove elements of a set B. That means A intersection A minus B is this one. This region with shaded by red color. This one. Now, uh, characteristic function chi of A. A is any set. A is a set. And suppose we define chi of A. that is a belongingness of that set, whether element belongs to that set or not. That means here we have only two possibilities, either element in a set or not in a set. Okay, so chi of a of x is equal to 1 if x belongs to a, otherwise that is 0. That means we call it as binary also. Okay, that means here we have only two possibilities. Now, what is the motivation to define fuzzy set? Suppose if we have a class of 7 PhD students and we ask them who does have a driver's license. So either have a driver's license or do not have a driver's license. There are yes or no possibilities. Yes or no. Okay, S means 1, no means 0. So here I put 1, 0, no, S, S. That means this one is S. Okay, and 2 are no. Now, if I change my question, who can drive very well? Who can drive car or any vehicle very well? Then, so in this case, we have to put some number. That means membership value. So this says 0.2, that means 2%. This says 4, 0.4. This says 0.8, then 0.1, then 0.7. 0.7 means 70%. This means 100% can drive very well. This one is 80%. This do not have a license. Then 40%, 20%, like this. That means here we have introduced membership function. Okay, so for fuzzy set, we required this one. So a fuzzy set is a set containing elements that have varying degree of membership in the set. One means complete in that set, and inside of a set. Elements in a fuzzy set, because their membership need not be complete, can also be member of other set. Because if we have a and B set and membership value of x in A is suppose 0.2, then x in B must be 0.8. That means 20% part is in A and 80% part is in B, like this. Eliminate inverse of membership values using a function theoretic form, and that form is like this. So here an object has a numeric degree of membership lies between 0 and 1. So meaning of 0 means object is not in the set, and this means 1 means that means number lies between and 1 means partially in the set. Okay, partially means that may be 0.1 or 0.9, meaning of partially. Now, this one. If U is collection of objects denoted generally by elements is X, then fuzzy set A in U, that is X is element and mu A of X, that means membership function. Okay, and this one is a function mu A, membership function is from U to 0, 1. Okay, now just give me 1 minute. So this mu A membership function, this is a function from u to 0, 1. This one is closed interval. This one is a not set 0, comma 1. 0, comma 1 has only two elements. Here we have an infinite elements. Now, what is union function? Union set in characteristic function. So, chi of x in union A union B, that is maximum of chi of A, comma chi of. And same philosophy is used for fuzzy. So for A intersection B, that is minimum of both. Then for complement, that is 1 minus original. In fuzzy set theory, we have a same. So mu of x in A union B, that is maximum of mu of A, comma mu of B. Then for intersection, we have a minimum. Then for complement, we have a 1 minus original. And De Morgan's laws also hold. Okay, and in fuzzy, in general, we have A union A complement is equal to whole set in general set theory. But in fuzzy set theory, we have a different, that is not equal to X. Now, pictorial representation of union and intersection complement of fuzzy. Union means this one is A and this other one is B. So union means both. Intersection means which complement is this one. So here in set A, membership value of this one is, suppose this may be 0.8, and in set B, this is part of set B. In set B, that is 0.2. So minimum between 0.2 and 0.8 is 0.2. So take 0.2 in this way. And complement means, suppose this one is original set. This one is original one. So membership value is 0. So in complement, that must be 1. For 0, 1, like this. So opposite of this one. Now, suppose here we have A and B. A set is like this. Membership value function is this. This one is set B. Then what is A intersection? This believe is A intersection B. Common minimum between A and B. And this one is union. Union means take complete A and B. And this one is complement of A, opposite of this one. So complement will become this blue. For 0, that will become a 1. Then for, suppose we call as a 0.1, that will become 0.9, like this. Now, it's a time to add new flavor, that is a rough set theory. But for rough set theory, we require some granules nothing but equivalence class, because nothing but equivalence class is nothing but partitions. Okay, so to learn partitions, that mathematician, that student must know what do you mean by equivalence relation, because equivalence classes give partition of that total set. So here, equivalence relation means a relation which is reflexive, symmetric, and transitive. A relation R defined in a set A is said to be equivalence. So what do you mean by reflexive? Every element is related to itself. For example, suppose X is set of students in one class, then M class. Suppose X is a set of students in one college. We consider one college. and X is related to Y if and only if X and Y belongs to same class. So X and X belongs to same class. So this one is reflexive. Symmetric means whenever A is related to B, then B must be related to A. Okay. So this same example, this one is symmetric, because if X and Y belongs to same class, then Y and X must be in same class. And transitive means if A is related to B, B is related to C, then A must be related to C. Okay, that means same example. X and Y belongs to same class. Y and Z belongs to same class. That means XYZ belongs to same class, means X and Z belongs to same class. So this one is reflective, transitive. That means in a college, equivalence classes are, suppose there are suppose 4-year degree college, suppose that is a BTech, BE college, engineering college. So the first year students, second year students, third year students, and fourth year student, last year BE students. So these are equivalence classes. We can subdivide that into again divisions also. Okay, but I am talking about first year, second year, third year, and last year. So these are equivalence classes. Now, what motivate us to define what we call define rub set theory? Dear student, philosophy of rub set theory help us to win elections, because generally every party has suppose 10 to 15 fixed vote, 10 to 15%. Suppose averagely 55 to 65, this much percentage of vote is fixed. And winning election, that will decided by some people who do not belongs to any party. That is just only 15%. That means that are on the boundary, and all parties are trying to connect with these peoples. We can observe this from many years. This is the real life situation where we use rough set theory, but we at that time we didn't know this approach is known as a rough set theory. So here we have our target set is this. So if we have some partitions, equivalence classes, we call it as granules. Then I define some set X. Then this complete square lies inside of that this red line, that is a black square. So this is in lower approximation. That means completely inside of that. That means complete vote of a party. And these are on the boundary. To define set theory is solving rep set theory. Now, rough set theory is very interesting. That is just like probability theory. We don't require any preliminary mathematics. That one is, we don't require some additional mathematics. We don't require trigonometry, integral calculus, differential calculus. This one is so simple. Just like probability theory, we don't require any preliminary mathematics for rough set. It provides efficient methods, algorithms, and tools for finding hidden pattern. Now, this one plays very important role. We can find hidden pattern of a data. Then it allows to reduce original data. That's why I put this picture. Data size is not important. Size of that, what we call sample is not important. Yeah, population is not important. By using theory of upset, we can reduce original data. So how to reduce original data? That means we can remove some dependent observations. If X is there, then Y must be there. So instead of considering X and Y, consider only one. So this is the logic behind this, but that formulation part is different. Then it allows to evaluate the significance of the data. This one is very, very important. And it helps us to make decision rules. That means predictions. We can form some decision rule. We can form some prediction rules. And one of the best feature is it is easy to understand. And it offers straightforward interpretation of obtained results. It is suited for concurrent, parallel, or distributed processing and not need any preliminary or additional information. As I told you, just like probability theory. Now, it's a time to define rough set. Rough set theory is associated with lower approximations and upper approximations. So, what do you mean by lower approximation? That means certainly classified as a member of X. That means lower approximation of X, this is equal to X such that R of X means equivalence class of X. So equivalence class of X is completely lie inside of X. Okay, so we have to identify how many equivalence classes lies inside of X. That belongs to lower part. Okay, and then upper approximation is classified as possible members of class. Classified as possible members of a class. That means we don't know whether that belongs to that class or not, but that is on boundary. That means from that equivalence class, one element belongs to that set, but others are not. Okay, one element belongs to, five elements belongs to set, but others are not. That's why we write this as classified as possible member of X. That means intersection of that equivalence class with set X, that must be non-empty. For example, suppose we have this 16 equivalence classes. This one is our set. Dear student, is it properly visible to you? This this table having 16 different colors. Okay. So this one is first equivalence class, second, third, fourth, like this. We have 16 equivalence classes. Now, my set is, suppose I define some X set and that set is like this. Okay, I take this part also. This one, my set is like this. So, dear students, Now tell me how to define lower and upper approximations. Lower means completely lies inside. This blue and yellow, these two completely lies inside. So this belongs to lower approximation of this set. And upper approximation means that is lower plus boundary, because intersection of this blue with x means this total. Blue with x is non-empty, so this blue belongs to upper approximation. This yellow belongs to upper approximation. This belongs to upper approximation. This one is also in upper approximations. All this belongs to upper approximation. Okay, so this one is lower and upper approximation. Now, rough set means if, okay, before that we will define what do you mean by negative region. Negative region means that is up u minus upper approximation. That means this one is negative region with respect to x. In any situation, we can't convert these voters for this party X, because they have a difference in their philosophy, so couldn't convert such type of vote. So this one is negative for with respect to this X. And then boundary means u minus X. So boundary means from this upper approximation remove elements of lower approximation. So that is a boundary. Okay, and this boundary means upper approximation minus lower approximations. So suppose my set is like this. Suppose my set is this one. So boundary means this belongs to boundary. Okay, this one, this side, this granule, this granule. So this one is boundary. If a boundary is non-empty, because there is a one possibility that boundary may be empty, boundary may be non-empty. If a boundary is non-empty, then that is known as rough set. A set X is a subset of U. U means universal set. Set under consideration. With respect to an equivalence relation R, R plays very important role. How you are dividing that set into disjoint subsets, that plays very important role. So equivalence relation R on U. If the boundary set is non-empty, then that set X is known as rough set. For example, this yellow is lower approximation. Lower plus this color, these two are upper approximations, and upper approximation boundary is this one only. These elements belongs to boundary. Okay, so this one is a fuzzy set. Okay, same situation is there. So depending upon this, how many possibilities are there? That means here we are talking about U and phi set. So set under consideration is U, then empty set, and we have a lower approximation and upper approximation. So remember one thing. For lower approximation, that lower approximation may be phi, because suppose my set is like this. Then in this case, lower approximation is phi. Okay, then lower approximation may not be phi. For example, this line here, yellow part is in lower approximation. So for lower approximation, we have two possibilities only. And for upper approximation is equal to universal set, or upper approximation is not equal to universal set. Suppose my set under consideration is like this. this complete set. Then here upper approximation is whole set. So combine these four possibilities together. So phi u, phi not u, then not phi u, and not phi not u. So there are only four types of rough sets. We divide rough set into four categories only. First is are definable. That means lower approximation is not equal to pi, upper approximation is not equal to u. This is R definable. Then roughly R definable. Then internally are undefinable. That is, lower is equal to empty and upper is not equal to u. Then externally are undefinable. Lower is not equal to phi, but upper is u. Then totally are undefinable. Lower is equal to phi, and here upper is equal to u. So there are only four possibilities. Now it's a time to define soft set. To define soft set, we require some function. We require power set. So let us define it. Let U be an initial universal set. Okay, universal set with respect to some with respect to your philosophy. Then EU with a collection of all possible parameters or attributes with respect to U. This one, all possible parameters or attributes with respect to U, where parameters are the characteristics or properties of objects in U. That's why I call it as attributes. Then P of U be the collection of all subsets of U, and phi stands for empty set. Here P of U means power set, collection of all possible subsets of that set. Suppose my set is suppose A comma B only. Then in power set we have a phi, we have a singleton A, then singleton B, and this AB. So this one is a power set of this one. A pair FA, A is a set, A is a subset of E. And what is E? Collection of parameters. A is a subset of E. Is called a subset over U, universal set. And that function F is defined as F from A to P of U. So we write this image as FA. That means we denote pair of subset as F comma A. F is a function, A is a subset of set of attributes. Okay, so this one is a subset. That means one element is associated with many elements. That's why, but in a function, what happened? Suppose here we have a 1, 2, 3, and here we have A, B, C. Now this my one element is associated with 3, 4, 5 elements. That is not possible in function. So what happened? To make it is a function, we denote this as a one set, one element. Then A comma B as another element. A comma C as one other element. Then B comma C as one new element. Then singleton A, B, C, and then accordingly we can define. If this belongs to all properties, if this have all properties, then we can denote this as one single element. Without power set, we can't define function. That would not be a function. That's why to define function, we convert that element. We make a group of elements and we call it as a one element. So automatically this satisfies property of a function. Actually, this is the beauty of mathematics. We add some flavor. If we found some restrictions, if we found some problems while defining that, then we resolve that problem by defining new term. So this flexibility is in mathematics. Uh, okay, then types of subset. Null subset means image is empty. Just like here we are talking about image. So image here in power set present, then we can call it as subset. F of e is equal to 5. Then null subset. Absolute subset is f of e is equal to universal set. That means that complete ABC. And then intersection of two subset, that is this h of e is equal to f of e intersection g of e. And their union is different. That means suppose in union we have a one set and in another set. Suppose this one is a, this one is b, and here uh, for this one is common in both a and b, and this one is in a but not in b, and this one is in b but not in a, this part. So this is equal to f of e if e belongs to a minus b, because we define subset by using f function. So this one is same as fa, this one is same as intersection. We take f of e union f of b. Okay, here for intersection we take union of both. Now this is about union and intersection of subset. Now let us mix these two flavors together, rough set and soft set. And then later on we will add one more flavor, that is fuzzy set theory in rough soft sets. Now let us understand beauty of this concept. Because for a rough set we required some lower and upper approximation and some boundary. So this one is not soft rough set, this one is a rough soft set. So our main set is a rough set. So try to adjust properties of rough set. That means try to define lower and upper approximation. So E is subset of U, set of parameters. U is universal set. R is equivalence relation on U. Fe is a subset. Then we define, because F is a function for this E. Now, lower approximation is defined as, this one is first upper approximation. This is a function. This arrow from left to right means upper, and right to left means lower. So this one is e to power set. This one is e to power set. But meaning of this function is different. So meaning is upper E is equal to upper approximation of f of E. Lower subset is equal to, this one is a lower, this is equal to lower approximation of f of E for every E belongs to set. And this one is upper soft set, and this one is lower soft set. Now, this is abstract term, so I will explain in detail through example. Now, how to define rough subset? That means here, first we defined upper and lower subsets. Now, if upper minus lower is non-null soft set, in general, that is non-empty. But we are thinking about rough and soft. So non-null soft set. Okay, and if these two are equal, that will become crisp set. That means our regular set. Always remember that lower approximation is subset of general set, and general set is a subset of upper approximation. So lower rough soft set is subset of rough soft set, and rough soft set is a subset of upper approximation of rough soft set. Okay, that means philosophy is like this. Lower is subset of a general set is a subset of upper approximation. Now it's a time. Now we require this much theory uh, to to handle our case study, how to select a life partner. Now let us start. Suppose you want to select a life partner. Let us take one case. Suppose a boy want to select a life partner. Now for that, we should define some attributes of that girl. So what would be the attributes of a girl while selecting life partner? What we think? We have to remember one thing. I am selecting this case. We have to select a reverse also. Suppose girl want to identify one boy for a life partner. So what would be attribute that particular boy should have? So for that, so vice versa, you can apply. This one is a one some what we call one logical example. So parallelly, you can handle any case. So here we assume that a boy want to select a girl for a life partner. So attributes under considerations are, so here my U set is available possible girls for that particular boy. How many? 7. So yes, 7 some that particular family have a 7 patrikas. We call it as a patrika in Maharashtra. So yeah, biodatas of 7 girls. So this one is universal set. This is for possible alternatives. And suppose attribute set A is, because for soft set we have attribute set. Suppose I consider here only 4 attributes. You can consider n number of attributes. So first one is even represent beautiful. This may be the first requirement of a particular boy. Then modern. Then this one is E2. Then E3 is educated, desired education. Desired education, that may be medical, that may be pharmacy, that may be MBA, that may be engineering, that may be just graduation, that may be just 10th pass. That depends upon that particular family. And good family background. Okay. So here I consider only 4 attributes: E1, E2, E3, E4. Beautiful, modern, educated, and having good family background. Now, consider a soft set. So, how to consider soft set? This one is F A set of attributes. F is a function. Now we have to define function. So, if I write FE3, now here E3 means educated. That means that girl is educated, like this. Now, suppose one of marriage bureau give you 7 patrikas, 7 alternatives, and as per your opinion, this one is beautiful, this one is modern, this one is educated, and this one is good family background. These are attributes. As per your own opinion, if have like this. As per your opinion, first 4 are not beautiful. This E and G are beautiful. Then this one is not E2. Attribute E2 is modern. So A is modern, B is not modern, like this. 0 means S, 0 means no, and 1 means S. So we have data like S, no. Because it is very difficult how to decide beautiful. Definition of beautiful, handsome is different as per opinion of that concern concerned person. So just we write 0 and 1 as per the opinion of that particular boy. I think in our tradition, that particular boy or girl do not have a complete freedom to select life partner. Because we are living in a family, and in our family we have to consider opinion of many people, many family members. For example, in some family we have to consider opinion of father, mother, then older brother, sister, yeah, younger brother, sometimes uncle, sometimes best friends. Okay, that may be anything, but there are many experts. So this is as per my perception. Now we have to incorporate perception of that experts also. So for simplicity, I consider three experts, their opinion. Now, by considering that data, first expert says T1 is first expert, specialist, we call it as a specialist. So T1 says first three are not good. D, E, and G, these are good as per the opinion of first. Then opinion of second expert, A is good, C is good, and G is good, not others. But opinion of third is different. So opinion of third expert is 0, 1, 1, 0, 1, 0, 0, like this. Now how to decide? That will be more confusing because this one is imprecise data. I like this one. How much? We can't say. Why? We can't say. That's why we call it as imprecise data. And it is very, very important to understand analysis of that imprecise data. So from this table and this table 2, here we have only yes or no. And by using yes or no, that means if I ask you how many of you are clever, would you answer my question? This one is not difficult because cleverness is not properly defined. So here, just like we can't answer some questions in imprecise data is in terms of this pattern only. So how to handle this? So for that, now we have to integrate philosophy of rough set, soft set, and fuzzy set together. Now for that, let us define a soft set. Okay, so here soft set is so this one is image of T1 is DEG. Here we have a 1. So we write DEG. Image of T2 is A, C, and G. So ACG. And image of T3 is in Maharashtra, and what happened? One of the party had not taken care of their original party members. That is BJP. BJP had not taken care of their original party members. That's why uh, they have faced many problems in that election. Okay, that means here we are taking care of original also. This original also, and this by lower and this by boundary also. Okay, so there should be a good balance, otherwise you will face a problem just like elections. And for that we have to define, so what to do for our 100% suppose say customers, yeah, voters. These lower means 100% voters. This average means at present we have this much voting, and these are on boundaries. If we focus only on boundaries, then our 100% voters may divert. So there must be a good balance. So we have to define some what we call weight for all these, and that weight is, suppose I define 0.255 and 0.25. Okay, but how to incorporate all these together? And to incorporate all these together, here weight of first one is 0.25, second one is 0.5, and third one is 0.25. You can take any type of weight, but some must be one. Okay, that may be for 100%, that may be suppose 0.2. Here we have present, these are 100% voters. So for this one, we can take, these are previous voters. So you may take 4, and for this you may take 4 also. That depends upon that particular situation and that particular persons. Okay, then choice value function is defined as phi of hk is equal to 0.25 times lower, 0.5 times that original, and 0.25 times upper. Okay, these numbers may be different. That depends upon you. That depends upon your philosophy. Now, so for lower, that membership value functions are for upper approximation, that are 1, 2 by 3, 2 by 3, 1, 1, 2 by 3, 1. Then for given data, as per first opinion of experts, 1 by 3, 1 by 3, 2 by 3, this one. And lower approximation is 1 by 3. Membership value for A is 1 by 3, for B is 0, and like this. Now choice value function is, see here, I want to find this one. Choice value of A, that is 1 into 0.5. Okay, I write here 1 into 0.5. 0.25. This one is 0.2 plus 1 by 3 plus 1 by 3 into 0.5 plus 1 by 3 into 0.25. So what is this? 1 by 3, 1 by 3, 0.75. That means divided by 3 is 0.25, and plus 0.25 is 0.5. This one, 2 by 3 plus 1 by 3. So 2 by 3 into 0.25 plus 1 by 3 into 0.5 plus 0 into 2.5. This is 0.33. Then 2 by 3 into 0.5, 2 by 3 into 0.5. So this one is 0.8. This one is 0.2. And this one is 0.67. This one is 0.17. And this one is 0.67. So by incorporating all results opinion of everyone, our choice value function out of 1, that is 0.5, 0.33, 0.58, 0.4, 0.67, 0.17, and 0.67. Okay, so now write this according to decreasing choice value function. So ranking of life partner, and here ranking is this. This one is 0.67. This one is also 0.67. These two are same. This one is 0.5 and remaining as. So these two are equal. Now here we have a tie. Now if we consider these 4 attributes, here we have a tie. Now you can add one more attribute. It may happen that we are adding where they are living, where is job of that particular girl, what is height of that girl, anything that depends upon choice of that boy. If type is there, you have to add one more attributes. Otherwise, we have to select any one out of E and G. Okay. That means we are taking care of all things. You can add a number of attributes there. You can add what is the nature of that girl, whether that means that depends upon particular family. So you can write n number of attributes. You can take opinion of m number of specialist family members, and we can proceed this. So, and if you select spouse in this way, then we will minimize your futuristic problems and you will enjoy your happy life. So this is the special case study, how to select a spouse or life partner by using rough set theory, soft set theory, and fuzzy set theory. That means integration of these 3 together. So analogically, we can apply same thing anywhere if imprecise data is there. So applications of rough and rough set, soft set, and fuzzy sets that is used in marketing. Okay, I think all you are professors, you know now how to use that particular philosophy, where we can use. During pandemic, I have authored one paper that is symptomatic approach for prediction of COVID-19, like that. I have published one paper by using this philosophy. In that paper, we consider a data of COVID patient. In that, there are 10 symptoms. And out of 10 symptoms, we remove some dependent symptoms. That means we could remove at that time 6 symptoms, and at the end, we had only 4 symptoms. And after that, I had designed some decision rules. After having first 3 symptoms, what will be the probability of having COVID positive or COVID negative? Yeah, suppose particular patient have only 1 symptom, then whether to test for COVID or not, like that we have prepared some decision rules. So this one is very, very applicable in general life also, because nowadays it is very difficult to get precise data. And if precise data is there, then there are some statistical tests. We can apply that test also. Yeah, if precise data is there, then by your judgment you can decide. But for imprecise data, we require special theory. And these theories are developed to study only imprecise data. So in fraud detection, we can use this. So to predict cases in which credit and credit card transactions are not done properly, yeah. So in medical diagnosis, just I have explained my research on COVID. Then performance analysis that may be applicable in education and in industry also. Then case studies. We have a different case studies of this knowledge acquisition in nursing, yeah, diagnosis of any disease, yeah, medical database analysis, image analysis for medical application, then surgical wound infection, classification of historical pictures. For that also, we can use this. That means I found that in every field we can apply this one. So for social science and others, then conflict analysis, then social choice function. We have defined one choice function here. Here we have a one social choice function. Then rough sites in librarian science, rough site based study of voter performance. Just I have explained. Then analysis of test profile performance. Everywhere we can, even in game also we can use this, but your data must be perfect. So without perfect data, perfect means that may be imprecise data, but that must be primary data. If you are working on secondary data, so that will create a problem, because if someone had done some mistake while collecting data, then your result may be biased in that case. So for this one we can use. And then real-time applications, that is a pattern recognition, emergency room diagnostic, medical, then bioinformatics, yeah, everywhere we can use. So these are just few applications. This one is an online session, and 2 hours online session means very difficult for teachers to attend such type of session. So now this one is end of my session.
Okay, sir. Okay.
Dear participants, okay, now it's a time for discussion.
Okay. If anyone having a question, please ask to sir. Please ask question if anyone have. Okay, sir.
If there is no any question, then I think all are teachers. So
Okay, sir.
I would like to say something about how we are thinking. I think we all agree that time is alive. Okay, so you have to utilize your time very wisely. The second thing is, all of you know that there are two kinds of knowledge. One is general and other one is specialized knowledge. General knowledge, no matter how great in quantity, it would not be more beneficial for mankind. General knowledge means, suppose I know some general mathematics, some basics of mathematics. Okay, that is general knowledge here. And faculties of many universities, IITs, NITs, central universities, some private universities, colleges, possess every form of general knowledge known for civilization. They specialize on teaching knowledge, but they do not specialize on organization or the use of knowledge properly. I think all of you are agree with my statement. Knowledge is a power. Actually, I was agree with this statement, but when I read one book, then right now I was not agree with this. Knowledge is a power. It is nothing of the sort. Knowledge is only potential. If you have a knowledge and you are not doing anything, so what is use of that power? That's why I call it as only potential power. It becomes power only when, and if it is organized into def- definite plans of actions and directed to a definite end. That means without plans and without action, your knowledge will become potential power. No use of that potential. So try to organize your knowledge and use knowledge after acquiring it, and that will play this very what we call massive role in the development of society as well as development of individual person, yeah, institute of that particular person. Most of the times we are not thinking about why that suppose why we define here, why we introduce here Pajisek theory, because we have to define some choice. We have to define some choice value function. So we need membership value. So that means don't learn concept just like mantras. All of you know Gayatri mantra, but only 1 or 2% people know exact meaning of Gayatri mantra. In education system, we are working like this. We all are professors, but we are not discussing with our student about how many learning methods are there. We are professors, but we don't know how many teaching methods are there. We are just following someone. That may be your teacher, who you like more like that. But now it's a time, in any way, it's a time to develop your holistic and multidisciplinary persona, and that would help you to achieve unprecedented academic accolades. Otherwise, you will be just like normal professor. If you want to achieve different, then use your time very wisely and keep your big goals away from small mind. Keep your big goals away from small minds, because that people will divert. So don't share your ideas. Just work on your idea, achieve that your goals, and enjoy this teaching profession. Now over to you, sir.
Thank you, sir.
Okay.
Thank
I'm audible, sir?
Yes, you are.
Okay. So, on behalf of Department of Engineering Science, KJ College of Engineering and Mathematics Research, I extend my sincere thanks to our keynote speaker and resource person to Dr. Bhapkar sir, who spared time from his busiest schedule to give such useful information on rough sets, soft sets, fuzzy sets, and how to select a life partner, and application of rough sets and soft sets in marketing for detection and medical education and industries. So today we had an opportunity to hear your thoughts, and this will surely be going to encourage us in our future. So thank you so much, sir.
Thank you, sir, for giving me an opportunity to discuss my views with my friend. Most of the participants are my friends.
Okay, sir. Thank you for sharing so much nice information.